So Java 21 is a big topic. We have lots to talk about. So we're going to go basically over everything that happened after 17. I cannot give you a tutorial on everything. It's more like a showcase. And if you want to find more details, you can go to youtube.com/java or /@java. We can also dive deeper. So some of the topics, specifically the most interesting ones, I'm going to stay on a surface level. So my goal is to get through the slide deck as it is now in like an hour. And then maybe take a short break, something. And then we can dive deeper. There's specifically virtual threads and data-oriented programming that we can go deeper in that would otherwise take up like the whole hour at least, or maybe even more time. If you go to slides.nipafx.dev, you will see the slides already online, so you can already follow along. So as I mentioned, we have lots to talk about: pattern matching, virtual threads, string templates, a couple of API updates and additions, and then we can talk a little bit about performance and other miscellaneous additions. But before we go there, I want to talk about why even upgrade your Java version. And I'm assuming I'm going to talk to developers, so I'm assuming you're all interested in using the new version anyway. So maybe I can help you convince whoever in your organization thinks it's better to stay on Java 6 for another decade. So maybe I can give you some arguments there. So first of all, if you're on Java 6, 7, or soon 8, you have to pay somebody for support. And so that's something, that costs money. There's a dollar amount or euro amount to put next to that, and it's always a good argument to upgrade. A technical one is that the support in libraries and frameworks for Java 8 and before Java 8, even now, it's already tough. But Java 8 itself also is waning. I don't have the list in my head, but it's a lot of frameworks, Spring Boot, for example, and Jakarta EE and Tomcat and all of those who in the newest versions or in the soon-to-be released versions require newer versions than 8. And at the moment, where basically everything or almost everything still supports 8, an update is somewhat easy. You can update all your dependency to the newest versions, then do the Java update, and then you're good. In 5 years, you have to figure out what the newest versions of all of your dependencies is that still works on your Java version, and then pick those, and then do the Java update from 8 to 11 or 17, and then keep updating your dependencies. It's only going to get more complicated. But there's also a cost of not running on the new version. So the one was like there's a cost of running on an old version, but also not on the new version also has a cost. So I would claim you would have lower productivity. That should be kind of obvious. Like we're hoping that every feature that gets added to Java increases your productivity. So that means then by necessity that if you don't update those features, you're going to lag behind, and it's going to take you more time to achieve the same result. You have less observability into the runtime. You have a little bit less performance. I'm going to come to that a little bit later. The access to talent is harder. Imagine you're looking for a new job, and all things being equal, one company offers you to work on Java 21, the other offers you to work on 8. Which one would you pick? And specifically in a time where access to talent is challenging, there could also be an argument, and this is actually a good argument where you can try to rope in HR into the conversation. Be like, look, if we have new Java versions, we might find colleagues easier. Upgrade costs are going to only increase from here on, specifically for the reason that I just explained. But also, there's just no other way. Unless you plan that your project is dead in the next half decade or decade, you have to update at some point anyway, right? And I think that's a good argument. You have to make this investment anyway, and now it's cheaper than in the future. So I think that's also hopefully a helpful argument to convince other people in your organization. I have a few things to talk about how to best upgrade, but let's not go into detail on that. I'm going to stick with this one. If you have the chance, and there is other benefits besides Java upgrades, keep dependencies and tools up to date. That's the easiest way to make sure that you can have a somewhat easy experience when you upgrade Java. There's more to do, and if you have any questions about that, I can come back to that later. I want to go a little bit into how to upgrade your Java version. Or to prepare that rather, and I want to invite you to build on more Java versions than the one that you're running on. So specifically if you own a backend that you run on your own in the cloud or on your own premise, then you have control of which Java version it runs, right? And then it would be easy to just say, look, we're running on Java 8 or 11, we're just going to build on that version. And that makes sense if you just look at, I want to get my build into production. But if you also want to get your code base ready for the future, I would invite you to build on more Java versions. So build on your baseline Java version, the one you require. Build on every supported Java version since then. If you're on 8, at the moment that would be 8, 11, 17, 21, and very, very soon 22 for 6 months. Build on the latest versions, that would soon be 22. And build on the early access version of the next early access build of the next version if you have the chance. Now, this sounds like a lot of builds and a lot of effort. Most build pipelines make this somewhat easy, but it still takes a lot of time and potentially a lot of resources, even monetary resources if you build in the cloud. Now, you don't have to build every commit on every Java version. You can, but you don't have to. This is not about making sure that every single commit works perfectly on a Java version you're not even running on. This is about finding out whether there are issues in your code base that you have to address before an upgrade. And a good way to get there is to build, for example, nightly maybe, right? Have a full build every night, and then you'll see in the morning the Java 17 build turned red. Some dependency that we pulled in doesn't work on that version yet. Now you're aware, you can track that. You also have to build the whole project. If part of your project doesn't work, try to figure out how to exclude that from the build. Maybe it's a Maven submodule or a Gradle subproject. Don't build it on a new version. Maybe it's some tests that fail. There are annotations, for example, in JUnit 5 where you can just say, don't run this test on this Java version or higher. Find a way to build as much as is feasible, as often as makes sense for you. And that way just get an insight into whether there are any issues with an upgrade. Because, while Java is backwards compatible, there are always some changes, some small, a few larger ones that are at least good to know about. I talked a little bit about upgrading and about versions that have support. I have a long spiel about what does long-term support mean and who offers it to you. The basic version, the TLDR, is long-term support versions versus long-term support versions. Versions with long-term support are not technically different. They are not the full versions, whereas Java, whereas a version before that is like an alpha or beta release. Don't let anybody tell you that. That is not true. From a technical perspective, each individual release has the same level of quality. The difference is who gives you updates. What are the details? Do you have to sign a contract? Do you have to pay somebody? All of those things are different, but those are things outside of the group, of the community that builds the technical implementation, that builds the JDK. The longer version is this. I'm not going to go over this. If you want to know, search for this video on YouTube, or if you have the slides, you can just click on this image. Java 21 is no LTS version. I was accused of clickbait title, but it is technically correct, which is the best kind of correct, as we all know. The reason is not that you do not get long-term support for Java 21. The reason is that no version is a long-term support version because the Java versions are released by a community which does not know the concept of LTS, which is OpenJDK. Again, if this was mildly confusing, that's good. I want to raise some questions so that you go look it up and that we're all better educated about what LTS really means. Okay, all of that out of the way. Since Java 21, it does make sense to talk a little bit about LTS, but let's now talk about features. We're going to start with pattern matching. Specifically, we're going to look at how this is a new form of dynamic dispatch, and I'm going to explain towards the end what I mean by that. We're writing a little simple application which scrapes GitHub projects. The idea here is that you give it a URL, it connects to that URL, presumably it's a URL to a GitHub page, and then it figures out, is this an issue page or a pull request page? And if it's one of those two, it tries to find the links that link to other parts of the project or to other projects, even on GitHub, or even to external sources. And then it follows up on those links. And when it finds an external page, it stops. When it is an error, it stops. But when it finds another GitHub page, it keeps going. So it scrapes GitHub starting from a root page. And then you have to put in some condition where it stops. Otherwise, you're going to end up scraping all of GitHub, because sooner or later some project links to another project, and then you're going to find everything. Okay, and then it does some further processing of these pages. So it creates instances of these four types: GitHub issue page, GitHub pull request page, external page, error page, which all implement the page interface. Now, what features could all this have? Now, the demo app that I'm going to refer to here has none of these features because these are actually complicated and don't fit on slides and everything. But hypothetically, these are some features that you could imagine, right? So, for example, if you find all these pages, you could then make up a graph. You could display this as an interactive graph. You could compute some graph properties. Maybe you want to categorize by topics. You want to run mood analysis. And if you're doing all of this fancy stuff, maybe you want to charge people for it. So I can imagine there are lots of things that you could do with these page instances. Now the question is, how do you implement that? So how do you implement, have this page interface, and then you have all these features that you want to apply to that. And one way to do that would be to have the methods on the page. So, maybe the page interface has a method that says draw, that gets a 2D canvas and then draws itself on the canvas. Or it has a process payment method that somehow gets, I don't know, like a payment processor or something, and then it uses to process the payments. And what would happen if you would do it that way is you would have the page interface and all these very different parts of your project that do payment processing and mood analysis and graph analysis, and they would all collide in this class, right? You would have one class that knows your entire system, or at least this part of the system, which is terrible. And you have one class that knows everything, all the use cases are going to collide there. It's not a good way to write this code. One common way to make sure that you have operations that are separate from a data structure but still get some kind of compiler support is to use the visitor pattern, which works and is the best solution that is available in such situations, but it's also not exactly a great feature that is a pattern that is very enjoyable to use. I still remember when I was very early in my developer career how much the visitor pattern stumped me, because you end up in this visit method and then you're like, visit this. And like, what? What's going on here? So it's not trivial. And so we have a better solution now with pattern matching. And that's what we're going to look at. As I told you earlier, this is like the brief version of pattern matching. If we have time at the end and you're interested, we can dive much deeper. So pattern matching uses these ingredients. If you see a number in a circle, that's the JDK version in which a feature became final. And from then on, it's not going to change anymore, and you can use it. If you see this nasty box, it means that my code font doesn't yet support the newest Unicode version. So that should be a 21 in a circle. That's unfortunate. So that means these features, they were partially, some of them were, all of them actually, were available a few versions earlier. In those versions, there are preview features. Preview features also have very high quality. They are ready to be used in production. They're not like buggy or terribly slow or have security vulnerabilities, none of that. But they might still change in the future. Whereas Java, once a feature is final, usually doesn't touch it anymore. These features, while they're in preview, can still change. And so it does not make sense to write a lot of code against it. So I would not recommend to put preview features in a large code base into production. But if you have internal projects, demo projects, stuff like that, go ahead, use these preview features. Just don't write more code against such a feature than you're willing to rewrite should the feature change or even be removed, which never happened so far, but still. Okay, so we have these things. We're going to go through them slowly. We're going to start, this is the approach. We're going to make page sealed, and I'm going to show you what that means. We're going to implement the features as methods outside of page. So, so all these payment processing and, drawing on a canvas happens elsewhere. And they all take a page as a parameter, and then they switch over it. So let's see how that works. Let's start with the sealing. Sealed types limit inheritance by only allowing the subtypes that you mention. So let's talk about interfaces because that makes it simpler. Right? Usually when you have a public interface page, everybody can implement that interface. Everybody on the same JVM means not only your artifact, but also other artifacts. And in most cases, that's good. Right? I'm not saying that's not a good thing. If you think about the collection or the list interface, you want this to work that way, right? You want your code to work with an unknown number of list implementations if you use some kind of dependency that returns a specialized kind of list. But sometimes it's not what you want. Sometimes you are in a situation where you kind of know that there are only certain implementations in your code base and you don't expect your code to just work if you throw an additional implementation. And for such situations, and generally for situations where you want to use pattern matching, sealing interface is recommended. If you seal an interface, you write sealed here, and then comes a permits clause, and that lists the specific types, these could be classes or interfaces, that implement that interface in this case, right? So they all implement this interface. These are specific classes in this case, and no other type is allowed to. If I create a new type of page that says implements page, I will get a compiler error. That's the important part here. Okay, so I've written this public sealed interface that permits all of these types. And what that gets me is the ability to switch over the page. So I'm getting a page as input. I can switch over the page, and this is weird, right? Like in the past, you could only switch over very specific kinds of types. It was like int and enums and strings and those kind of types. Now you can switch over whatever you want. And if you do that, then what you're doing is you're doing a so-called I would say like a more complex switch or pattern switch, where you say, okay, let's switch based on the type. Switch over page, and then I say, in case it's a GitHub issue page, which was one of the types, right, that implemented page, create a new variable of that type that is called issue, and then on the right-hand side, well, it's not the right-hand side because the slide is too small, but on the hypothetical right-hand side of that arrow, you can then use this variable as an instance of this type. So what this does is it checks whether it's of that type, then it does the cast, and now you can use issue. And that means here in these branches, like I've always just called some method here, right? But of course you could do more interesting stuff in these branches, in this switch block. If you do that, here issue is an instance of that type. So whatever method is on that type that is not also on page, you can use that, right? It is now an instance of that type. And only when it is an instance of that type will that branch be executed. And conceptually, it's not exactly the implementation, but conceptually it works like the normal switch. It just goes from top to bottom, finds the first branch or the first condition that matches, executes the branch on the side. Now I want to point out that here there is no default branch. I just list all the 4 types that are permitted. That will become important later. Later is now, because important now. Because the important part is that unlike an if-else-if chain, the switch wants to be exhaustive. What do I mean by that? If you write it, you could write this as an if-else-if chain, right? If page is instance of GitHub issue page, and then you could use the new pattern matching in switch. If with instance of, but let's ignore that. You could write if page is an instance of this, do the cast, do the method, call the method, else if it's an instance of that, blah, blah, blah. And then you go if, else, if all the way through. And if you do that, the compiler is okay with that, but if you forget a type, it doesn't care, right? As you know, the method would just maybe it just contains the first 3, then you just have branches for the first 3, and if the 4th type comes in, you fall through this if-else-if chain, and what happens then depends on the rest of the code. And if you're lucky, you find that you're in development. Otherwise, hopefully tests cover this. In the worst case, you will find out at runtime that you ran through all the cases that you expected. So that's why we think that is bad code. That's why we usually don't want to switch, or why we don't want to do these type checks, because it makes maintainability harder. Adding new types leads to problems. But a pattern switch needs to be exhaustive. It needs to cover all cases. The compiler enforces this. And the way to do that is, or the best way to do that in a way that is maintainable, is to switch over a sealed type to make sure you have one case for each subtype, and then don't use a default branch. Because if you use a default branch, always all cases are covered, right? Whatever happens, you can always have the default branch. But if you can fulfill these 3 requirements, then adding a new subtype will cause a compile error. Right, so that's the point, right? So you get a compile error if you add a 5th type, and that's good. That's what the visitor pattern gives you as well. If you add another type then all operations that don't cover that type yet will have to be updated before the compiler is happy. And you get the same logic here, just simpler. Now I mentioned dynamic dispatch earlier. Dynamic dispatch is a concept or like a process that makes sure that you have running different code, that you run different code for different types. We all know how that works intuitively in Java. If you have a list interface that has an add method, and you have a linked list and an array list implementation, and you call on some kind of list that you get the add method, you know that if it's a linked list, this method is executed. If it's an array list, the other method gets executed, the other implementation. They have the same contract, but based on the type, a different method is executed. And dynamic dispatch is the process that accomplishes that. And we have that as a language feature in Java. Exactly as the example that I just told you is via inheritance. You put on an interface or on a superclass, you put the method, and then the implementing classes provide different implementations, and that way you get the dynamic dispatch. And as I mentioned earlier, that's good. Like, I'm not saying that that's not the way it should be, but that makes the method part of the API. Now the add method on the list is part of the API, which makes sense in many cases, but sometimes it doesn't. Sometimes you don't want to have this type as part of the public API. Gave you the example earlier, page should not have a public API that talks about payment processing and mood analysis and all of that in one class. If you don't want to make it part of the public API, the regular approach used to be the visitor pattern. And by the way, if you don't know the visitor pattern by heart, good for you. Don't look it up because you're not going to use it anymore. But then the whole visitation part becomes part of the API, which is not exactly low effort. Like it's kind of clunky. And overall, the whole usage of that is somewhat cumbersome and indirect. With pattern matching, now you get a much smaller impact on the type. You have to make it sealed. And you have to be aware that a sealed type, you cannot have a dependency that just adds direct implementations of that type. That doesn't work. Adding a new type to this permits clause is a backwards incompatible change. So it's not like this comes for free, but overall the impact on the type is lower and using it is very straightforward. And that's pattern matching as a new form of dynamic dispatch in a nutshell. Now, if you want to learn more and we don't have time later, I will send the slides to Andreas so you can look them up afterwards. Everything green here is a link. Pattern matching in the Java object model is an article by Brian Getz, who works at Oracle on designing these features, not alone, but he's the lead of this project. There's a video on the Java YouTube channel. Java 1 brings full pattern matching. If you want to see it in action, the GitHub crawler that I just presented is an actual project. It just doesn't do anything fancy. It just prints a few lines to the terminal. But it shows that in practice. Okay, that was a short version of pattern matching. I have an even shorter version of data-oriented programming for you. Now, data-oriented programming takes the stuff that we just talked about and also adds records to the mix, and then tells you how to design solutions for problems in a specific way. What it tells you is use Java's strong type system to model data as data. Specifically, that means model data as data with records. If the input that you get is a user with an address, create a record user that has, probably a name as a string, and then an address. And that address is probably also another record that has a street, a zip code, that kind of stuff. Model the data as closely as possible with records. They make that straightforward and easy. They're also shallowly immutable. They can be deconstructed and reconstructed easily. They are the way to go if you're in a situation where you just want to model the data as closely as possible. If the data has alternatives, use sealed types. Maybe a user doesn't have an address. Maybe the user has a contact information. There could be a sealed interface that permits email, an actual address if you want to send letters, or Germany, definitely a fax number, phone number, that kind of stuff, right? And that could be an alternative. So you would have a contact information interface that allows these different implementations. So that models the types, the information. Now you want to model the behavior. For that, use methods, potentially static ones, that live elsewhere. Like they don't live on the data that you're modeling here. They live in the types that process the data. Use exhaustive switches, meaning switches that cover all subtypes and avoid the default branch, so you get compile errors. And then you can use the pattern matching to destructure polymorphic data. I didn't show you that so far. I'm going to show you that if you want me to dive deeper into this. Now that means you're going to deal with a lot of kind of at least shallowly immutable data. By shallowly immutable, I mean records have all final fields. But if the field is a mutable list, that list can still be changed, right? So if you want to have like actual deeply immutable data structures, you have to add a little bit of extra work. But still it gives you something that is like it wants to be immutable, and that comes into a static method, which you could call a function if you'd want to, and then presumably produces either state change or maybe just another result as output. And so that somewhat puts it closely to functional programming. It isn't quite functional programming, but it's very similar. You're still talking about data and functions, but the first priority here is the data and not the functions. So I've never used functional programming in real life projects, but my feeling from my experimentations is this is probably like 80-90% similar to functional programming, and the difference comes from the trade-offs, where you would want in functional programming, you want to focus on composable functions. Here you want to focus on using data. Now the important part is, I'm not here to tell you that functional programming is the future and you shouldn't use object-oriented programming anymore. Now if you are of that conviction, that's fine with me as well. This adds more functional programming capabilities to the language. But if you are happier with object-oriented programming, that's fine too. The main application for you then, if you're not sure where you would want to use it, is in small subsystems or systems that are very focused on data. So if you have a large problem, we usually, as object-oriented programmers, we usually tend to think about how can we use encapsulation and internalizing of state changes to turn this large problem into smaller subproblems. And that's great and that works well. But there comes a time when you start to make these problems very, very small, that at some point the extra effort of this encapsulation and the pain that can come from mutable states, specifically shared mutable states, outweighs the benefit of that kind of design. And in those situations, when it's either you start to have very small sub-problems, or you're dealing with a subsystem that just deals with data. So for example, something that maybe like a nightly batch job that reads a large CSV file, takes in the data, works it around a little bit, and then pushes it into a database or whatever. That kind of stuff, right? Where it's like you could see this as the entire project is just taking in data, transforming it, and pushing it back out. And in those situations, data-oriented programming, or even functional programming, right, works really well. So if you're not sure where to use this would be my recommendation, which look into it. If you want to learn more about this, again, data-oriented programming in Java, that's an article Brian Getz wrote on InfoQ. We have also a video on that. That's, I think, the same one I mentioned before, but it goes to pattern matching and then data-oriented programming a little bit. This one goes a little bit deeper. And again, the GitHub crawler tries to use that style. Okay, that was it on that topic already. So if you feel like, okay, this sounded interesting, but I'm not sure about all the details, that's good. I got you where I wanted you to be. We can ask questions now if you want to, and then we can dive deeper later if you want to. So you got any questions on this whole pattern matching, data-oriented programming? Yes?
The exhaustive switch statement, you can also do that with enums, can't you?
Right. So the thing with an enum is, yes, you can do that, but yeah, I think you cannot actually sure whether the compiler, Target probably knows.
For a switch statement, the compiler will allow you to have non-exhaustive.
To be incomplete, right? Yeah.
For switch expression, you have to.
Yeah, switch expressions always have to be exhaustive. Oh, right, yeah, because you could already write switch statements that switch over an enum and that are incomplete. Then you do not get the check. So if you only list 3 out of 4 enum constants, the compiler will be happy.
But this is basically like a legacy problem.
Yeah, exactly.
It would be designed like this, but
yeah.
For compatibility reasons.
Yeah. So I think allowing non-exhaustive switches is now considered a design. I don't know what the word mistake, but I can't come up with a better one. So let's say mistake. The problem though is that Java really doesn't allow you yet to do it the other way. For example, if you would require all switches everywhere to be exhaustive, then you could never switch over an int unless you add a default branch. But there's no way in a switch at the moment to express, in case it's a positive number, do this, in case it's 0, do this, in case it's a negative number, do that. That doesn't work in a switch. You can only do specific instances. So unless you want to list all 2 billion int variables, which I'm pretty sure the Java compiler will not allow you to, yeah, you cannot have an exhaustive switch without a default branch.
I'm thinking more of the other case where I do have an exhaustive switch,
Yeah.
but I really shouldn't, because maybe it's an enum of error codes and it's supposed to be extended. Then I get a compile error in the next version.
No, you wouldn't. So if you have a switch over an enum, a switch statement. A statement is one where you just write switch the thing, and then you have the code. Right. Then you don't have to be exhaustive. That's fine. You can just list 3 out of 5, and you're good to go. If you want to actively design your code so that it can deal with unknown cases, you would add a default branch. In the sealed instance, you usually don't want to. Like in the deeper dive of this, I can actively show you how you would avoid the default branch intentionally to force these compile errors. But if you are absolutely 100% sure that all new cases are happy in the default branch, which I would argue is a very courageous assumption, but then you can do this, yes, definitely. And in the new code too, right? Like nothing stops you from putting, from leaving these 2 types out, just put default branch here. That's fine, it works, because it is exhaustive. It covers all input cases. The problem is, it's basically too exhaustive because it will always cover all input cases, because whenever you add a new type, it can always be the default branch. So my argument to avoid the default branch is to make sure that you get a compile error under the assumption that that is a maintainability benefit. Does it answer the question?
But in the default branch, you can work only with the page object.
Yeah, exactly. The default branch. I mean, many default branches, you know this, right? So at least in my experience, most of my default branches throw an illegal argument exception anyway. So they're like, I don't know what this is. Give me more information. So That's, I think, is a common approach. Like putting actual logic in a default branch can be the right solution, don't get me wrong, but it's always risky because you're always assuming that every addition in the future will always be fine in the default branch. And I think that's just often not a good assumption, not a valid assumption. Okay, let's go to virtual threads. Again, short version. We're talking about a hypothetical web request, right? So writing a web backend and it gets a REST request or an HTTP request. And so what does your web backend typically do? It starts to interpret the request, right? Maybe there's some JSON to parse, some domain instances, some domain objects to instantiate, test some business logic. Sooner or later, you probably want to start asking the database something, and that takes a while. Takes you a long while, like on the order of hundreds or thousands of times as long as the rest of your code. Like it's like a, rule of thumb, but like in a simple process, this can take. So it's much slower. Is what I'm saying. And then once the database is done, you process the data for the response, which is usually just the inverse, right? You take the SQL, you just like figure out the information that you need, probably apply some business rules, and then you send it back. So like it's very simple. Create, read, update, delete, a CRUD application follows this logic. So how's the resource utilization, specifically the JVM resource utilization? Right? Like the database might be super busy. If you're not like doing all the cloud stuff, it might even be on the same system, which is unlikely, but still. So it could be that your system is using its resources quite well, but much more likely is that the system runs your JVM and not much else, and your JVM definitely isn't busy in step 2. It does nothing basically. So the question is, how would you implement that request? And a simple approach would be a synchronous one. Your application apparently has a unit of concurrency, a unit of things having to happen concurrently, which is requests. You have requests arriving at the same time, you want to deal with them at the same time. So you map the application's unit of concurrency to Java's unit of concurrency, which is the thread. So you're saying, okay, every request gets its own thread. That code is simple to write, depending on the business logic. But the threading itself, simple to write, to debug, to profile. All tools in the Java ecosystem are geared towards this. They all accept this as working fine. Like you have something like thread locals, for example, loggings. You have logging contexts that work based on that. All of that just works fine. The problem is you block threads on certain calls, as I just described in the database case, right? So you block the thread. And this thread that you block in this situation, in this hypothetical, is what I would from now on call a platform thread. A platform thread, that's the typical Java thread you would know before Java 21, is just a thin wrapper around the operating system thread. And that operating system thread is not free. It's not terribly expensive, but it's like maybe a megabyte or 2 of overhead. It takes a little time to spawn. It's fine if you have like hundreds or thousands of those, tens of thousands, hundreds of thousands, you start to come into real problems. If you want to have millions of threads and each of them takes a megabyte, you already need like terabytes of RAM just for the thread instances, for nothing else. So sooner or later, you're going to run into problems. And that can lead to a case where the number of threads is actually the limiting factor, where your CPU still sits at like 10, 20%, but you cannot increase the number of threads because the system's out of resources otherwise. And that can lead to low throughput. And for many Java applications, if you're not Netflix, that could be fine, right? But there are a lot of applications out there, specifically if you count not by lines of code or by number of projects, but maybe by amount of euros running through those applications, or by the number of users that they have, that definitely cannot afford this. So somebody had a smart idea, which was, if threads are expensive, maybe we should only use one if we actually need one, and not have hundreds or thousands of them sitting around waiting. And then you would use non-blocking APIs. That could be future or completable future, or it would be completable future. In Java, you can go all in and use reactive streams. This code is, most people agree, harder to write, although there are people out there that say, no, they do actually like the reactive streams, building blocks-based API. I would probably one of them. I kind of like the normal stream API for that exact reason. It has like predefined building blocks. If you know them well and you can see their combination, it kind of makes sense to you. It feels to me like there's a split between how many people find that harder to write and how many people enjoy writing it. But I found nobody so far in these talks, and I make this claim a lot, that told me, no, debugging and profiling is much more fun with asynchronous APIs and reactive streams. Apparently nobody is in that camp. And that alone is, of course, something that if you put something in production at this level of performance requirements where we want to go this far, then apparently debugging, specifically profiling and optimization is important to you. And then asynchronous programming, making that more complicated, is not ideal. It's incompatible with synchronous code. If one of your dependencies doesn't know that you're doing this, that's a problem, because then it starts blocking these threads. But if it all works out, it does share platform threads. And that's great. So if it all works out, you can have as little as 1 or 2 threads per core running a system with like hundreds of thousands of concurrent users, because it uses these resources so well. And then you can actually have like a high CPU saturation and use your memory for more than just thread instances lying around. So this can lead to very high throughput. And what you have here is a conflict between simplicity and throughput. And this conflict is what virtual threads want to resolve. A virtual thread is a regular thread. This kind of weird font that I'm using here is my code font. So I'm trying to tell you this is an instance of the thread class. Of course, it's a subclass, but still. So everything that deals with threads automatically works with virtual threads. Has a low memory footprint in the kilobytes, bytes, small switching cost. And it's scheduled by the runtime, not by the operating system. But the important part is it requires no operating system thread when waiting. And hence you can have many of them. So the idea here is to think about them like you think about virtual memory, which is probably not a lot. Like I learned how virtual memory worked back at university, and I'm not saying this knowledge isn't important. It's cool background information. And I also know that in some situations it becomes important actual engineering, but most of the time, for most of the people, it doesn't really matter. There's a certain amount of memory, and whether the operating system is actually lying to you and there's not that much memory doesn't matter. Think of virtual threads the same way. Yes, you do not actually have unlimited operating system threads, but it doesn't matter. The runtime is managing it for you in a way that you can ignore this fact until you can't. But that moment happens rarely, just like with virtual memory, hopefully. So let's do something fun. Wait, was that a typo? Oh, there's an I here. This should be a U. So let's do something fun. Let's create 1 million threads on this lousy little laptop. So this is one way to do this. I have a new executor here, which has the very handy name, new virtual thread per task executor, which creates for every task that you give it a new virtual thread. And so from 0 to 1 million, what I'm doing here is I'm submitting a task that sleeps for a second and then returns a number just so I have a result. And then this executor here is auto-closable. So the end of the try block waits until everything else is done, until all of this happens. Okay, so I'm starting here 1 million things that each wait a second. If I would do this with regular threads, well, first of all, there's a real risk that I would just try creating threads so fast that my machine crashes. But even if that doesn't happen, this thing has 8 cores, 16 with, 4 actual cores, 8 with, what's called the hyper thing that doubles the number of threads, that thing. So we have 4 cores, and I don't know, whatever, doesn't matter. Point is, you would think, right, if you have 1 million, you divide by the number of cores, that's how many seconds it takes, because they can only wait one after another. And you can then increase that number until you run to that limitation of how many threads you can have on that machine. If you do this with virtual threads though, on this machine, and I just used 8 gigabytes for that, this is the runtime for different number of threads. Now, very, very importantly, did this while I was sitting in the train, listening to music on the side, had like my email client open. This is not a performance benchmark. You're not going to take this away home and say, like, okay, now I know how fast virtual threads are. This is just as a demonstration of what is possible. I mean, it also doesn't do anything, right? It just sleeps. I'm just showing you this to see how many virtual threads you can have at the same time. And you can see here that until you go like to 100,000, you don't even hardly notice. The system obviously takes at least a second to run, but I can have with just the 8 threads or whatever, I can have 1,000 threads waiting basically at the same time. And once I start to go above 100,000, it starts to become noticeable. But even 1 million threads can wait in just 6 seconds, which is pretty fast, given for this lousy machine. So what I'm demonstrating here is virtual threads make waiting basically free. One thing I should point out though is that virtual threads are not faster threads, right? If you get down to it, and actually like in specific situations, there's a slight overhead, right? The way that they work, there's a slight overhead there. It's very minute, and it doesn't matter in most cases. But specifically, they are not faster. So if you have a problem and you're using it, you have a large problem, and you're using, let's say, a parallel algorithm that splits this into as many tasks as you have threads on the machine, and then deals with this graph problem or whatever it is in like 8 parallel batches and then combines the results. Stuff like that, where you use parallelism to optimize wall clock time. In those situations, virtual threads will do nothing for you. Actually, there's actually a risk that it makes things worse. This is for concurrency situations. This is for situations where you have external processes triggering new threads in your system, like external requests, and where there's a lot of waiting involved. This is where they shine, right? So they're not making things faster. They're doing the same thing in more or less the same speed, but if there's waiting involved, you can do more of that at the same time. So you remove number of threads as a bottleneck. And as is with bottlenecks, the next might be just around the corner, right? Could be the case that your app cannot actually scale to 1 million virtual threads because each thread lugs around 2 megabytes of on-heap data, and then you run out of memory again. So don't expect a 10x or 100x improvement just because of virtual threads. It's possible, but it's not that likely because your application probably does more than just sleeping. But this specific bottleneck goes out the window. And that means that many things we do today, like for example asynchronous programming, become much less essential. And what you stick with though is that you have the application's unit of concurrency, so external requests, and Java's unit of concurrency, threads, one-to-one, which keeps debugging and profiling everything easy. So when the workload is not CPU bound and the number of concurrent tasks is high, then this gives you simplicity and throughput. So how would you do this? Mostly, if you write a backend, the web framework or the web server creates your threads. You're usually not doing this yourself, right? And these frameworks do offer, or will soon offer, easy configuration options. We're not there yet, but we're getting there. So Spring Boot 3.2, which was released late last year, actually does make this very easy now. You can just write spring.threads.virtual.enabled is true, and then every endpoint runs in a virtual thread. That's good. Quarkus picked a different approach. I'm not entirely happy with that, but whatever. They're probably knowing what they're doing. You can add an annotation, run on virtual thread, for example, to this endpoint, and then that specific endpoint runs in a virtual thread. Halidon, starting with version 4.0, which I think is still a release candidate, just runs everything in virtual threads. That's really interesting. So web servers often have a very asynchronous internal engine, Netty, that tries to optimize specifically for the problems that we just described. So using asynchronous programming internally to make sure that it can handle many concurrent requests. Now, Halidon decided to instead throw all of that out the window and re-implement a web server that, the project name was Nima, re-implement this web server that is very simply written, like it just creates a thread whenever something comes in, but it will be a virtual thread, and they achieve comparable performance. I'm not skilled enough to understand the details of these performance comparisons. I also think it's kind of challenging to apply them because I'm pretty sure it depends on applications. So I think they're playing in the same league, in the same ballpark of performance, of memory consumption. I think that's the important part. Specifics, if they are so important for you, whether one of them is 2 or 5% faster than the other, you would have to benchmark yourself. But I think what comes through here is the simplicity with which you can write code. I think that's the more important part to focus on. If you want to learn more about this, the JDK Enhancement Proposal 444 contains a lot of information on this, and there's an article on parallelism and concurrency, which makes this distinction between parallelism to optimize wall clock time. You use platform threads. Concurrency is many requests from the outside world. Use virtual threads. That goes into that. And we have a video on that as well. Okay, I'm going to skip the underload part, and we're going to go to something that I did not put in the table of contents, but we have to talk about. And that's stuff that goes out the window with all the new stuff coming in. So if you are using one of these features in your Java 11 or 8 code bases, be aware that they're already gone. You just didn't notice yet. So these things were removed: RMI activation, nashorn, concurrent mark sweep, garbage collector. They're out. There are a lot more things going on right now, so that any dynamic agent can connect to any running JVM by default. Again, this is the Java 21. Remember the JDK 21 icon. This will soon stop. You can still attach dynamic agents, but you will have to allow it at startup in some future Java version. That's the goal here. Microsoft decided that they don't want to maintain the 32-bit x68 port anymore, which I guess it's fair enough. Finalization, security manager, those are long-running projects. I expect these to still take some time, but they will still be gone nonetheless. They're already deprecated for removal. So the question is not, will they be removed? So the answer to that would be yes. The question is, when exactly does it happen? It's a slow-moving process. It's not only slow in the outside world, in the community, also within the JDK, a lot of code uses those two things and needs to be slowly rewritten and cut out. The last three, I expect an earlier disappearance. Applet API primitive wrapper constructors. That means if you have a new double or a new integer in your code base, those will soon be gone for Valhalla reasons. The replacement is super easy. You have to go instead integer dot value of or double value of or whatever, right? So these primitive wrappers, they will be gone. This, I think, fixing this is probably just you could do with the regex, but I think open rewrite. Probably, if they don't already, we'll probably soon have recipes for that to do that in your entire code base. Right, so those things, look into that. I have a part of agents and dynamic agents here. If you want me to go into that, let me know. The same for the other part. So if we can go into details here, if you're interested in any of these, we can discuss that ad nauseum. But for now, I want to skip to the last slide in this section because we're going to have more links. I made a video about that as well. That goes through each of the deprecations, except the two newest ones. Explains why those things are deprecated, because it's not like, when they're bored, the OpenJDK folks just go through the code base and just shoot random things. There is like purpose and meaning behind all of this, which I mostly skipped now. I explained that in the video. I can also explain it if you have questions, and then you can prepare your code base for those future Java versions. That's a good example, by the way, for building on new Java versions. If you build on JDK 21, then you will get tons of warnings that you will not get on your JDK 8 code base. And so then you will be noticing that. You will see, oh, wait, so these are things that I should be aware of. That triggers you to look these up and tells you, okay, maybe now is not a great time to add new code to finalizers, right? So information like that can be crucial. And I made a longer video about how to upgrade to Java 21 specifically with like all the minor little things that change, like Unicode updates that break daytime parsing in specific circumstances, but nonetheless. So there's a lot more there. Okay, now let's go back to what was in the original table of contents. Let's talk a little bit about string templates. So we have like a few more features and we take a break and then we can see what else we can dive into. So in Java, composing strings is kind of cumbersome. Let's say I have a property that I have a variable that I call property that has last name as a value, and I have a value that's called doe, and then I want to do this. Select star from person P, where P dot last name is value. So this is a way to put the string together with plus. I can use also string formatting. You can use message format. I think those are like the options. Maybe there are even more. That works, right? We've done stuff like that. Hopefully not exactly that, but stuff like that for a long time now. The reason why we hopefully didn't do exactly that, it comes with the free SQL injection. But why is this so cumbersome, right? Like other languages allow stuff like this, where you just write select star from person P, where P is then whatever. Like I use backslash curly braces here for a reason, but many languages use something like dollar or dollar curly brace, right? And we just embed the variables here, which is great. Now you can get your SQL injection much faster. And this is not just about SQL, right? In general, the text that we create, the strings that we create in a program, are in many, many, many cases not aimed at humans. Some of them are. Error messages, UI texts, stuff like that, right? But many texts that we build are not meant for humans. They're meant for a machine that reads HTML, JSON, YAML, whatever, SQL. And that means there's always syntax. There's always some kind of check that you should ideally apply to make sure that the string you just created follow these format-specific rules, which is why you usually do not create JSON as a string. You usually go to JSON and say, I want to create a JSON string that matches this JSON object, and then you give it like some kind of map that looks like, that can be mapped to a JSON. So you need to follow these format-specific rules. So string templates tackle both of these problems. They tackle the verbosity of concatenating strings, and they tackle, and that's very important, these format-specific properties of these strings that you want to create. So this is a preview feature in Java 21. As I mentioned before, that does not mean it's crap. That just means it might change. So if you write bunch of code based on that. You might have to rewrite a bunch of code based on that. So I encourage you not to do that in your large in production code base. But again, there are many other code bases probably around on your machine. Then maybe some of them you can give this a try because you're okay with rewriting some of the code in case something changes. Two things are happening here. Well, actually kind of three things are happening. So first thing is I'm using a text block, the three quotation marks here. That feature was finalized in Java 15 and is completely orthogonal to what I'm showing you here. I'm just using this because in this specific instance, it's what makes the most sense and makes the most readable code, but it has nothing to do with it. You can use string templates with regular string literals or with text blocks. The two important parts are, one, I can actually embed variables here, so my code highlighter doesn't know, but / curly brace escapes basically the string. I'm getting out of the string and I'm saying, okay, I want to reference a variable or any kind of expression, really. You can put all kinds of stuff here, maybe stream pipelines, whatever. I would generally recommend not to keep it simple, but some simple arithmetic or maybe a method call, that's all fine. And so that's the first part. I am embedding expressions here. And the second part is this str here. I mean, then there's the weird syntax, right? So this is called a template processor. It takes this template, string template, and turns it into the string. Now there's an asterisk here, so we're going to come back to that into a string in a second. This looks weird. What kind of Java syntax is that? This is an instance of an interface. We're going to come back to that later. And this is just .process, just calling a process method on that interface and passing the string template as a parameter. So this specific feature got this syntax sugar because if you have to actually call str.process, then no way is this simpler than just the plus sign, right? And everybody would hate on Java again because it's so verbose, and at least in this instance, that would be absolutely deserved. So it has this shortcut. Now, those of you, using other languages where you have like a much simpler way to, call function types, for example, you might think like, can I do this with a function? Can I stop writing at apply? The answer is no, you cannot. This feature is not expanded to other interfaces. I'm not sure. I'm pretty sure that has not been on the roadmap. Otherwise, I guess I would have heard about it. But right, so you can only use with string templates. You can get rid of this .process parentheses. Okay, so let's talk about the template and the string. First of all, two examples. One template processor, this str thing. Oh, right, str, that's just an object, an instance that is defined somewhere, and that is basically imported here. And because you're going to use str a lot, you get the import for free, just like all the stuff that's in Java lang. So you don't have to import. But you can imagine this being a static instance somewhere in some class, and you have a static import for that at the top of this code. Okay, so what I'm doing is I'm creating a little payment slip. Apparently there's a variable description, price, quantity. I'm doing some simple arithmetic here, creating this this output down here. It's all fine. The unfortunate side effect though is that apparently I have to pay in parts of a cent, which is challenging. So maybe I want to round here. And one way to do this would be to use the other embedded or the other template process that is shipped with the JDK at the moment, which is FMT. I don't know why str and FMT. It feels to me like we're back to the times where like variables were expensive, or letters were expensive. I guess FMT stands for formatting. Maybe it's to keep it short. I don't know, whatever. What it does is it interprets these string.format substrings. I always forget the details, but I think this means I want to have 5 positions and 2 of them are after the dot, after the decimal dot, and this is a float, if I remember correctly. But the point is, this section of the code, this section of the string, this specific formatter interprets everything that comes before this embedded expression, or it looks for whatever comes before the embedded expression. Is it one of these kind of substrings? And if it is, it applies that formatting to that variable, and then of course it removes that section of the string. So you can see how this is much more involved than the str we had earlier. The str really just does concatenate, put everything to a string builder, return the result, done. This one actually has to do some back parsing, some interpretation, some removal of the string pieces before it puts everything together, because the %5 blah 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 of course is missing here. So you can see this template processor does a little bit more. But why are we talking about string? Oh, sorry, yes.
Just can I also call methods inside of string template?
Here, yes. Like you can call whatever expression you want. You can put that's what you meant, right? Like here in this. Yeah, was that? Yeah, you can use whatever, everything that's a Java expression can go there. As I said, you can have like a
Even another string template you can put.
Yeah, exactly. That's actually kind of interesting. Like if you put a template together, like it sounds nonsensical, but once you start using templates, you soon run into a situation where like, oh yeah, no, I have like this part, and then there's an inner part that is dynamic in a different way. So now I want to embed the one in the other. It happens. As I said earlier, like the interesting thing about nesting string templates is it kind of stays readable because you're mentally still looking at mostly a string. It becomes weird if you put like actual long code. I mentioned earlier you can't put like a stream pipeline here. That's pretty long, right? That would make it harder to read.
That would basically the next question. What about when I get, first one, when it is executed and what do I get when I have an exception? What is the call?
Right. Okay, so this is not magic. You can assume this. What would happen here is at compile time, the compiler creates a call that will create a new string template and that passes these arguments. So assume a string template is something that takes all the string pieces and then all the evaluated expressions. And just like in a normal method call, when you call a method and some of the parameters or some of the arguments that you pass are itself expressions or other methods, then they will be evaluated first. So at runtime, this will be evaluated. And once the evaluation is done, it will be passed to the string templating. So if this expression throws an exception, you will just see the exception here. Yeah, so this is like, and the string formatter also can throw exceptions. We'll see that in a second. Okay, so that's why we talk about strings all the time. The idea here is that we start with part are strings, some parts are values, and then we want to validate or sanitize that. That was what I said earlier, right? When I talked about JSON and XML and SQL and all that. And that means you have to at least partially parse it to figure out what is the actual statement here. And when you've done all that, then why would you dumb it back down to a string? Sometimes it's necessary because it goes over the wire, but in just as many cases, maybe you're passing it on to a different part of your system that could actually deal with not just the string, would actually be okay with getting an SQL statement, with getting a JSON object or whatever. So why the detour? Why do we do this parsing and then we parse it again down here? And the answer is no reason. So str is a single instance, as I mentioned before, of this interface. Processor is a nested interface. It's on the string template class. And this is what it looks like. Public interface processor, 2 generic types. This has to extend exception, but it doesn't fit on the slide that well. So, and then it has a process method that I mentioned before. And so this process method can throw an exception, but also it can return any result. It does not at all have to be a string. And that is super powerful because this way you can use this feature of combining text and values to immediately create the technical objects that you probably want to use. So for example, a hypothetical SQL template processor could do this. Select star from person P where. So this looks like the buggy SQL injection kind of code that I showed earlier. But this template processor knows about SQL. It is written for SQL. If you instantiate it, because it doesn't have to be a static instance, if you instantiate this with your database connection information, it could do exactly the right thing. It could go to the database, create a prepared statement that contains 2 holes here, and then fill in the values later. And then there's 0 risk of injection. That would be the way that, for example, if you do this, something with like Hibernate, when you create a request, what they do. So this looks like the buggy SQL injection code I showed you before, but it's not. It's safe. It knows about SQL. It applies the rules, and then it returns a statement right away, because why not? And this could be immediately executed by the database without doing an additional, without having JDBC do an additional parsing run over this. This not only returns a JSON object, it also looks like JSON. It combines the text blocks, the fact that you don't have to escape a single quotation mark or the double quotation mark you don't have to escape that. So this thing looks like JSON and also is verified to be JSON and also returns a JSON object. Again, hypothetically, right? So this could be in a library like Jackson. Maybe they have, if you want to, sometimes you need a string. Maybe this you could call toString on this. Maybe you have a JSON underscore str processor that returns a JSON string that does all of this and then calls toString on that. Who knows? But the gist is you can have all these domain-specific rules checking your interpolated string to make sure it's correct and then return the rich I don't want to say domain object because that's not usually a domain, JSON or SQL statements, but often more it's like technical things you want to create here. And we can all do that, right? All we need to do is implement that interface. So, string templating simplifies string concatenation, allows us to apply domain-specific rules, and incentivizes us to do it the right way, because you always need to put some template processor there. That's really interesting. This is not a technical limitation. Java could have easily said, well, if you don't put any template processor there, we're just going to call the str one. But then the good solution, which is to sit down and think about the processor and pick one, is more cumbersome and longer than the just do it variant. And so intentionally, the just do it variant is not actually shorter. That's why you always have to put str there. That's what I mean by incentivizing doing it the right way, because you're incentivized to think about what you want to do in that specific instance. Okay. I'm sorry, I've been a little slower than I intended to be, even though it probably didn't feel like that for you.
One question.
Yes.
And in the standard VM, there are only these two, str?
Yes, str and fmt are the only ones that are in there right now. I'm not sure, I think the one that makes most sense to embed would be the SQL one, because Java SQL is a module, is a part of JDBC, is a part of the JDK. So I'm not sure whether that would make sense. Maybe it doesn't actually. I'm not, because it works best if it talks to the database. I'm not sure whether you can plug that in somehow. So at the moment, those are the only two. I'm not sure. Yes? Three.
Is also raw processor, but it's unlike.
Oh, right. Yeah. Good point. I forgot about that one. If you actually want a string template here, an instance of string template, you can call raw here, and then you get a string template. And then you can evaluate it. Then you can pass the string template around if for whatever reason that's what you want to do. Good point. Thank you, Tage. Yeah. Okay.
But that's an OpenJDK stuff thing. So can you also create those pattern things, or do you have to wait that they are integrated JSON and all that?
Right. So all we have to do to use this entire system is to implement the string template .processor interface,
Okay.
and then put an instance here.
Okay.
So you can easily create your own.
Okay, wonderful.
I've already done that just for fun. Like this, for example, is fairly straightforward to implement, like a simple one. Like a more complicated one is more challenging. But if you just want to have like a one level deep JSON parser, it's super simple to do with Jackson. What you get is you get these sections, which the string starts here and ends here, right? So you get this as a substring, then you get this as a value, and then you get the next substring. And so all you need to do is basically go hunting backwards for that thing, put that as a key into a map, put that as a value into the map. Again, do this for all of those, for the JSON, then give that to Jackson and tell it, create me a JSON object from this, and then it can return this. So a simple JSON parser is straightforward to implement. It quickly becomes more complicated if you have nesting and arrays and blah, blah, blah. So then you need to put in more effort.
This JSON example would probably restrict where I could put my template variables. For example, here I have the JSON values, maybe the field names, but I would probably run into problems if I wanted to pass in like a string of 3 fields with values.
So maybe this could be a variable, for example, right? Maybe the attribute, the property of the object. That depends on what the parser wants let you do. So there's nothing stopping it from allowing that, but it would add complexity when implementing it. So it would be like the very simple one I just described. It's much simpler if you don't allow that. If you say no, you can only embed the values, the attribute names, they have to be as actual strings in there. Somebody, yeah.
This syntactic sugar with dot and triple double quote, is it specific to calling this process method on processor?
Yeah.
But if I have an implementation of that, would that still apply?
Yeah. So the processor.process method, that gets the syntax sugar. Nothing else does. But all of those do. So all of our implementations as well. Yeah. So for example, one thing, there are people who really like writing tests, like test cases in kind of like a free form string thing. And I was thinking, for example, you could think maybe there's a good way to have text here that describes the test's name and purpose, and then you embed the code that runs as a lambda, or run to complication there because you need a target type to cast a lambda. So it's not straightforward, or it's not. Rather, I think the result wouldn't be that pretty. But you could do this. JNet 5 has a mechanism where you can dynamically create tests at runtime. So you could come up with some kind of way to basically write your tests in Java much more like text plus lambda kind of thing, how you do it in some other frameworks or languages. And use a template processor for that, for example. And then you would also get the syntax sugar.
That would be something for JUnit Pioneer, right?
Yeah, yes. I actually thought about that already, but it's like, if you think... So the problem here is this is expected to be an object, and a lambda does not work if the target type is an object. A lambda only works if the target type is a functional interface. So to use a lambda here, you would have to cast it to something. And that throws a lot of the beauty of this approach immediately out the window if the code always has to have like a parenthesis something before that. Although you don't have to make it a supplier of test case, of course, you could create a specific interface that would be called test, or test, bad because also the name of the annotation. And then just cast a lambda to test. But anyway, yeah, so there's interesting things to explore here. Okay, should we still take this short break now? I'm not sure, like, I can keep going, right? Like, anybody wants like fresh air, drinks? Yes? No? Who would like to take a short break? Okay, then we keep going. It's like, I'm fine. Okay, let's talk about sequenced collections. The list embodies collections that have an order, meaning you expect the list to always give you the same elements in the same order unless you change something there. And it also allows indexed access. So it allows you to take like the 5th or the 10th element out. There are collections that have this kind of order where unless you change there's like a meaningful iteration order, but it doesn't allow indexed access. Sorted set, for example, uses the sort order as its order, but you cannot tell the sorted set, give me the 5th element. A deck, linked hash set, there are a few more. The problem is that there's a type for this, but there is no super type for this. There is no type for the concept. It has a stable and meaningful order without allowing me to get the nth element. And this is what a sequence is. So these new interfaces capture the concept of order. We have sequence collection, which will be the one we're talking about the most, and then we have also sequence set and sequence map. You can use this, as a parameter, as a return type for its type properties, but you can also use it to enjoy the new methods. So let's go a little bit over the methods. Let's go a little bit over the APIs. So let's say you want to have the first element of these types, of a list, of a sorted set, of a deck, or of a linked hash set. List get 0 is okay, I guess. We've got used to that. Sorted set first is nice. Deck get first, also nice. Linked hash set iterator next is terrible. Also, it skips the part where you get an exception if the linked hash set is actually empty. Although, that's probably what you would want if you get the first element, if you want to get the first element of the empty list. But still, not exactly beautiful. Now all sequence collections have a get first method. So all of these 4 types and more implement that interface. And now on all of them, instead of doing this, you can also now call get first. Immediately you run into the fun of a backwards compatible language. Sorted set now has first and get first. Because what else are you going to do? If you call it first, then deck has first and get first. So there's that. The last element is way less fun. This is terrible. I've written this more times than I can count, and every time I hated it. In this case, this is removal, but it looks the same for getting. Sorted set removal is, you can get the last element, but if you remove it, you have to pass it on. Deck has remove last, which, good. Linked hash set has just nothing. You want to get the last element? The only way to get there is to take the linked hash set, create a new collection, and then go through it the other way, which is, like, if it's a large collection, that's terrible. Now you can just call remove last. I'm just showing you some of the examples, right? We're going to see a full list later. You can reverse order very easily now. So list has a list iterator, something that not everybody knows, by the way. I barely ever use it, but it's pretty neat. So the list iterator not only has, in addition to next, has next and next, it also has previous and previous, but it also allows you to remove elements in place. So this this bootcamp, Java bootcamp question, or not bootcamp, this application question that you might get if you go to a company where they ask you interview question. How do you remove elements from a list while you're iterating over it? This would be one reasonable answer. You list iterator, because the list iterator can modify the list while it's iterating over it. You can tell it, like, you go iterate and you're like, oh, this element fulfills property, remove this element. But anyway, you can also use it to revert backwards, which is kind of nice. Navigable set has a cool thing, it's called descending set, which is again a navigable set, which is just a view on the first set. That's pretty neat. So you can do all the forwards iterating, all the things you usually want to do. You can stream through it, but you don't do it, you do it forwards on the view, but that is implemented as backwards to the underlying collection. And views also have the advantage that you can, that's very, very cheap to create, just like the iterators. Deck has descending iterator, which is an iterator, but it goes the other way. So it's not like cool like this, which can move both ways. It just moves one way, the other way. Again, linked hash set is nothing for us. Now we can just call sequence collection.reversed. And it makes sense to look at that for a second longer. So reversed returns a view that is itself again a sequence collection. And that means two things. First of all, calling reversed is cheap. Right? It's just a view, so you don't have to worry that it reverses or inverses like the entire collection. And because it's itself a collection, you can use any iteration mechanism that you like. You can use it to have a for each loop, you can do a stream on that, you can do whatever you want, you can create an internal array. All the things that you can do with these collections, you can also now do by simply calling reversed on the reversed collection. But also it's a view. Again, one part of that is that it's easier, it's simple, or rather performant to create. Another part, and depending on use case, there could be an upside or a downside, it reflects changes in the underlying collection. So here I create an array list, ABC. I do the whole putting list off into an array list because I want this to be mutable. I want this to change. So I have a list here that contains ABC. Now I call on reversed, which gives me CBA. I remove the first one, so C is gone. And indeed, if I now print letters, C is gone. So I think this is the better approach, to just offer the view, because if you want to have, if you need a copy of this that will not change with the underlying collection, you would pass letters.reversed to an array list constructor or whatever. So you can always still create a stable copy of this that will not change. But this is kind of neat. So this is a way to change the underlying collection through the view. Overall, what you get is this. Add first and add last, get first and get last, remove first, remove last, and then the reversed. And then for sequenced map, you get, if you call key set, you get a sequence set, and if you call values, you get also a sequence set or collection or whatever that returns, right? So you get the sequenced map is basically there to return you the sequenced versions of the interface it usually returns, so that you can then call on that. And sequence set only exists so that this returns a sequence set. It does nothing materially different, but when you call the reversed method on a sequence set, you want to still know that it's a set, that it has this property of every object only exists once. So that's why it has this override. Okay, now there's a little bit of a quiz here. I have a sorted set of strings. I create a tree set. And so a tree set puts things by default into the order that is their like natural order if they have one. Strings have a natural order, which is like just the lexicographical ordering. So if you create a tree set with BAC, again I have to put the list of thingy here, you get letters that's called ABC because they put it into the order which the tree set promises. The tree set says that. It says, if you don't give me a comparator, I will put these things into the order, in their canonical ordering, if that's possible. Okay. Now I want to add last D. So, when the method is implemented, we don't know what we're passing. D is good, D goes into that place, but I could also say add last, actually, kind of a bad example, because there is no letter before this. If you just say add last, and then I put the letter before that, right? So we have situations in which add last kind of makes sense, and we have situations in which add last doesn't make sense because the underlying collection does not allow the object in that place. So what options do we have? One of them is, it works always. You can always add an element. Because you're specifically saying, I want this at the last element. But that's terrible because sorted set explicitly says it will always be in the order. So if I add D, that's fine, but if I add a variable that does not belong to the last place, that sucks. So this working always, even though it would be correct in this case, is not a good idea. It could work if the value fits. That would be a reasonable approach, but it's kind of weird. So that means some at last calls work and some don't. So instead, we get this fun behavior where, remember, in Java, every mutable method on a collection can actually throw an unsupported operation exception, so that's what they do. So if you call add first, add last, or remove, no, actually removal always works, but if you call add first or add last on one of these collections that have a specific order that cannot be maintained for every argument of add first and add last, then it will just always throw. Just, so be aware of that. That you cannot trick the collection into doing things it's not supposed to.
But do you have the same problem with hash set and hash do?
So hash set does not implement sorted set because a hash set doesn't have this order thing, right? So the most sets, I picked specific linked hash set and sorted set because those are the specific subtypes that do have an iteration order even though it's a set. But the canonical, which is the hash set, set implementations don't need to do that. A set can do whatever it wants. So you don't have this order, right? Hash set is a good example. When you add an element, and that's the straw that breaks the camel's back, so to speak, and you get like rehashing and new buckets, the order is like whatever. And so in that sense, it's not a sorted set.
Wouldn't it be better that it works on a best effort basis? Add last is effectively add and collection does whatever it wants, but not throw exception.
Yes, you could argue that would be like a best. That's what this is, right? The best effort base. I don't know. It depends. Like
not if value fits. It always works. So
this one always works. So it breaks the contract. No, that's not a good idea.
No, in this case, so imagine that you have set BCD.
Yeah.
And you say add last A.
Yeah.
It would add A at the beginning.
Oh, so it wouldn't. Oh, so it
So it would work on best effort. So fourth option.
Oh, okay. So right. Okay, I get it now. So the best effort part is not if the value fits. The best effort part is if the position fits. And if the position doesn't fit, you just put it elsewhere.
If a position doesn't fit, put it
Okay.
where it should be.
Or you have an add method perhaps.
Yeah, that would make the Java doc of at last somewhat confusing, though. It would say like add in the last position, unless then whatever. So. So that's the problem, right? Like this one and the one you just proposed, but you're right, there's a fourth option. I didn't have that in mind.
That's the first option. It just inserts, but it breaks the contract of the method by inserting.
Yeah, it doesn't break the sorted set contract. It breaks, well, but the contract at last is a new.
Last says it is.
Yeah, but at last is new. You could define whatever contract you want. But yeah, I think that's the point, right? Instead of making because this already returns into one of those Java quizzes, right? Those puzzlers. And ideally, every complex language and API will create these puzzlers. But overall, the design goal should be to keep puzzlers to a minimum. And I think this would be a great one, right? Like at last, what happens now?
We'll ask Rafael Del Nero with his Java challengers.
Yeah, but this is not fun for him because this just always throws. So that's the good part. You cannot turn this into a puzzler; it just throws. Okay, but you can also use this as a type, right? So you don't always want to use, you know that instinctively if you have a method that takes something that is listy, you don't want to accept an array list, right? I should at least accept a list. I would argue in many cases a collection is actually also suitable. So the APIs that you create get some input and return some output, and you should, when those are collections, or in general, but specifically with collections because they have like a deep hierarchy, I would recommend to always consider carefully which is the correct type to accept and what is the correct type to promise that I want to return. So I think it's often actually collection as an input. For returns, depends on what you want to promise. And now I want you to consider new types when you do that. And this is where they fit into the hierarchy. So sequence collection inherits from collection, sequence set inherits from set and sequence collection. And then we have the whole map tree on the side here. And here you can see, for example, the ones that do not implement this are not mentioned, right? Like hash map is not mentioned here. It does not implement sequence map. And likewise, hash set is not mentioned there. You're only the ones mentioned that actually implement that new interface. So whenever you deal with collections, consider whether you want to now accept or return a sequenced collection, sequence set, whatever that is, if the order is important. It's just a new thing that we've been used to not being able to express. And now we get this expressive power. It might take a while to put this into this mental process of, okay, so when I'm thinking about this return type, is sequence something that I want to or need to promise? JDK Enhancement Proposal 431 goes into much more detail. And once more, there's a video on that as well, if you prefer, that explains that too. Okay, I'm going to skip the address resolution SPI though. I have a few smaller improvements for you. There is a new thing where you can to instantiate collections. So for example, if you want to have, if you know you're just going to get 50 elements and you cannot afford a resize of the underlying collection, let's talk about resizing first. An array list doesn't know how many elements you want to add, but since it's an array list, it needs an array, right? So it starts with some size, and when you add elements, once it runs out of space, it just creates a new array, which is twice the size, copies it over, and does stuff there. And of course, that's a performance cost. Now, don't optimize prematurely. It doesn't matter. Like 99.9% of cases, all our array lists are like, I don't know, 10 elements long. It doesn't matter if there's one array copy in the middle there. So 50 is not a great example. But let's say you have like 50 million. Then maybe it does become relevant and you don't want to have additional array copies because you know I'm running up to 50 million anyway. Why not create a 50 million array initially? So if you know the number of elements you want to store, this is how you create an array list of the right size. How do you create a hash map that can store 50 pairs without resizing? A hash map also has like an underlying array, has like this bucket structure on top of that. Anybody knows? You're not allowed to answer. So it's obviously this, which is not great. So I'm not going to go into the reason. I would have to struggle to put them together. I think I can, but let's not go there. The point is, it's not obvious. And now we get new methods. I don't like their name. I had a long conversation with Stuart Marks about this. He did not convince me, but it is what it is. So what you can now do, you can hash map, new hash map or hash set, new hash set, and you give it the number of elements or the number of mappings. And it will then create a map that will not resize up to that number. So you don't have to do this magic math in your head. Linked hash map and linked hash set also got those. So just in case, if you have code like this running around, where you have like specific numbers passed here, consider using these methods instead because they're more readable and they make clearer what you want to do. I mean, unless if you have like a very specific load factor, because these do not take load factors, but we ignore that. If you do math, we got a lot new stuff for you. So if you do int and long division, there are different modes now for rounding and for overflow handling, and it feels a little bit like a combinatorial explosion out of like, this is now possible and this is now possible. These are like 2 modes each, so you already have like 4 modes, and then you had like 2 other modes in the past, now you have like 16. It's not. It is what it is. Like if it's important, it's good that they're there. But yeah, you can do now ceiling modulus, which is kind of fun. It took me a while to understand this. So 5 modulo 3 is 2, right? 5 ceiling modulo 3 is -1. I'll leave that to you to make sense. But if you need to do this, there's no method for that. You can clamp, meaning you have a value, an arbitrary value, and you want to force it into an interval. It needs to be between 5 and 15. Finally, you can just pass, everybody has those utility classes lying around probably. Now you just pass it in, you get the same value back if it's in the interval, otherwise you get the min or the max, whatever is closer. Right, there's new stuff in strings and builders. So for example, if you want to have an index off, you can now give the end index. So you can say just search in this area. You can repeat stuff on string builder and string buffer. This method is already on string. So if you want to have a string 5 times, you can just say x.repeat5 and you get 5 x's. And you can now also say, if I have a string builder, repeat this string 5 times. Not exactly rocket science, but it's good to know that it's there. Actually, repeat is one of the biggest sources of my Stack Overflow karma. If you want to get Stack Overflow karma, I'll give you a recommendation. Follow the mailing lists, look for these little additions. And once they happen, don't tweet about it, don't blog about it, don't make a video, don't talk to anybody. Go to Stack Overflow and look for questions that ask, how can I do this in Java? And then you answer, in the new Java version, you can do this. This is great. Like, this is, I'm not kidding. I got for string repeat, I don't know how many upvotes. Because before string repeat, there's like a gazillion ways to do that. None of them suck. So there's like a big question and a ton of answers. And now there's a good, obviously correct answer. And that's mine. So, but yeah, for other stuff, you can do that. For example, if you're into emojis and want to figure out stuff like this, how do you do this in Java? Do you look up a table? No, now you just kind of have all these methods on character. Those are static methods, so you say character.isEmoji and then you pass in your code point and you get a yes/no answer.
What comes next is smiling emoji.
Yeah. Is it a positive emoji? Is it hate speech? Yeah, that's what's next. This is an interesting one. So if you're creating date times, or if you're formatting those rather, you at the moment had two options. You could create a fixed pattern where you define the pattern. You say it's hour, colon, minute, whatever. Or you take a localized style. So if you want this to look different depending on the locale, you would say, give me a medium length. But then you're bound to whatever medium means. Whatever medium means, that's going to be in there. You had so far no control. Either you apply full control and then it's either the same on all locales, or you have to do really a lot of work to make sure it's the right format for the locales you support, or you go with this, which is good until it doesn't fit anymore. Now there's an off-localized pattern for that's a static factory method for a datetime formatter. So you can say datetime formatter off-localized pattern, and then you pass it what you want to appear in the formatted string, and then it will find a locale-specific pattern that contains these values. I'm not sure whether it's only these values, but the point is that it tries to put those then, and it tries to put them into the order that you want. So if you, do I have an example? Yes, I have an example. So if you say, I only want to have the year and the month, you can say datetime formatter of localized pattern, this string, and then you will get this for USA, and for Germany you would get, I forgot, 2023-10 or something. I don't know what the answer is. But you get a different string in different countries. And if you want to run, that's the example. That's like a little bit of a longer example. I take 3 different locales and I do a little bit of formatting here, and this is what you get. This is my custom formatter. It's the same in US, it's the same in Belgium. This was for Devox Belgium. And it's the same in Vietnam. And the localized pattern looks like this. But if I only want the month and the year, this is what I would get out. So that's kind of neat. So if you deal with localization, look into this. Could be a good way, for example, for UI texts, right, to format them in a way that both make sense in that locale, but also do not contain information that you don't care about. They were also added to the datetime format builder so that you can work with those. Okay, the wide ride continues. More stuff is auto-closable now. HTTP client, executor service, fork join pool. That means you can use them at try with resources block, which is really cool because it makes it simpler to make sure that they do get closed under all circumstances. Right? The regular white try with resources is great, fully applies here, and so that's why you can use them now. Future got some new methods. So future now has methods result now and exception now. They're written for situations in which you know that the future already is done computing. This becomes specifically important in the context of the new structured concurrency APIs in context to virtual threads, but you still might be in a situation where you also have a future and you know it's done. You can now call result now and exception now, which means give me the existing result, and if it doesn't exist yet, you will get an exception back. But you can also ask for the state. Is it running? Did it succeed or did it fail or was it cancelled? So you can now have more like a manual tracking of the state of a future, if that's important. There is even more. They become more and more, like specific, not that universally applicable. Again, made a video on that. Jose Pomar goes over all the API new features that happened between 17 and 21, so you can take a look at that. Okay, now we're coming to shorter sections. Mostly, at least these two, because, wait, is class? I'm kind of surprised the class data sharing is already in there. There's like a very real risk that we run into a to-do later slide. We'll see. But either way, I'm not the performance guy. I can just give you like a high-level overview over these. If these topics are important to you, you should definitely follow up on your own, look this up, and see whether it works for you. So compared to other garbage collectors, ZGC optimized. So garbage collectors are always a trade-off between all kinds of different things. It's like a multi-dimensional cube that you can optimize all kinds of ways. ZGC goes in for ultra-low pause times, sub-millisecond pause times on the most gigantic heaps you can imagine. And as a cost for that, it comes with a higher memory footprint and higher CPU usage than other garbage collectors. If you don't, for example, like ultra low pause times, a great counterpoint is parallel GC. Up until Java 8, I think the default garbage collector. If you do not care about pause times because you're not building something with a UI or not building a web backend where there's like user input that you need to react to, you're just building a batch job. Parallel GC is unbeaten, and I'm assuming it's unbeatable because it doesn't care about anything. It just cares about throughput. But that might mean that you have to take like a half a second, 2 seconds, depending on heap size, 8 seconds pauses while it clears up the heap. Now that's okay if you run a batch job. All you want is overall as little resources as possible to go into garbage collection, so you're done the fastest. But if you have users, you don't want the 99th percentile to be like 5 seconds round trip times. So that's why in many situations where Java backend is running, you actually do care about pause times more than about overall throughput. So ZGC says, much like Shenandoah, by the way, we're going to go into ultra low pause times, and that's not entirely true, but consequences be damned. Whatever extra memory and CPU we need, we're going to do that. Now in Java 21, ZGC becomes generational. There is what's called a generational hypothesis, which means most objects die young and those who don't grow very, very old. Imagine you Spring app booting up, right? Spring at the beginning does like a bunch of stuff. It creates all these contexts and you know, beans and whatever. And in many situations, those just create when the program launches and they're going to exist until the program dies. This is like an extreme instance of the second one. Those objects who don't die young live very, very long. And then you call a stream pipeline. You call a stream, then you get, every call gives you another stream instance. In the end, you get an optional back, you get your value out. All of these, like in the perfect case where the Java just-in-time compiler can just put all of that code into one simple method, it doesn't even create instances anymore because they're all like just created there and immediately no longer needed. So then they don't even come to life, let alone dying. But most objects that do come to life die very, very soon. So this is a generational hypothesis, and that is true for most programs. It's not true for all programs, but it's true for most programs. And the garbage collector can make use of that. And it does that by tracking older and younger objects and then treating them differently. And ZGC did not do this, but it can do it now, starting in, I think, in 21. It's a generational feature. It's a, wait. No, it's not, what's it called? So you can use this flag. It's not an experimental feature. I thought it was, but it's not an experimental feature. You can just use ZGC, generational, and then you get that. So if you already use ZGC or are considering it for low pause time scenarios, give this a try. The feedback that we got was really, really good. But again, this depends on use cases. So give it a try. Ideally, you have performance tests for your app that tell you whether this worked for you or not. Otherwise, maybe you can observe in production. But yeah, if you care about this stuff, give it a try. It's probably going to do you well. So this benchmark, I double-checked. These are the right numbers, but the results are very extreme. So I'm not saying this will happen to your app. I'm saying this can happen to some app. So there was a Cassandra 4 benchmark that used ZGC versus generational ZGC. And well, maybe it just shows how really bad ZGC was, but it wasn't that bad. And what they achieved when they fixed the heap was 4 times the throughput, or when they fixed the throughput, 1/4 of heap size, which sounds ridiculous. That's why I had to ask, but it is actually true. So again, it's probably not representative, but it means that there is potential there. And so if you care about this kind of performance metrics, it could be something that's worth looking into. Again, there's a JEP. Again, there's a video, and this is a longer talk that goes into that as well. Now let's see what we have here. Oh, actual content, nice. Class data sharing allows you to shave off a few % of your launch time. So if you want to have a quicker boot, but you're not willing to go, for example, all in, for example, with Graal or something like Crack or Snapstart, I think is what's called on Amazon. So if you don't want to go that way for whatever reason, but you still would like to have, as I said, 10 to 25% improvements, you should look into class data sharing. This will probably become more relevant in the future with Project Leiden, which plans to put more improvements into this. This high-level overview, what does this do? A class CDS, let's call it CDS because it becomes less and less about class data and also less and less about sharing. So the idea here is that you create a file in addition to the jar, you can embed that in the jar though, that contains a bunch of information that usually the JVM creates when it launches. So the most obvious thing, and that was the original thing that was in there, is the actual class data. The JVM starts, your references all the you reference or your code references all the classes on the class path or module path. What it does is the JVM, I mean, it loads those classes, it verifies the bytecode to make sure it's all good, and then puts into a specific data structure. And it has to do that on launch every time. And realistically speaking, it's probably going to do always or almost always the same thing. And the only case when that changes is when you change either some configuration or more likely when you deploy a new version. So a lot of launches, if you launch your app a lot of launches will always produce the same result, and you repeat that work again and again and again. And the idea behind CDS is maybe we just do it once and then dump it into this archive. And the cool thing about CDS though is that it's failure proof. So if the archive does not match what's actually needed, then it depends. Like if your class on the damn, I tested this and now I forgot the result. I'm not sure whether if you change a single class but not its name, I'm not sure whether CDS would track that. But in general, it falls back to, oops, this doesn't seem to work. We're going to redo the work now at launch time, and then we'll give you information about that on the command line. So it's safe to use, safer, for example, than doing native images with Graal, where you cannot always be entirely sure what works or what doesn't until you try. But also, of course, gives you much less, right? 10 to 25% is not exactly the orders of magnitude improvement that you can get with native images, at least on launch time. And as I said, Project Leiden will probably put more information in there. There's been a great talk at the JVM Language Summit in August, which went over just how many additional boot time improvements are possible if we're willing to pull computation from runtime into build time and then dump that result into the archive. Again, a link. I should probably put the talk here, the Leiden talk here as well. Okay, a little bit on usability, just I think 1 or 2 slides, just one slide. There's a bunch of features that were added between 17 and 21. For example, the simple web server. So this here is actually a website that runs on localhost. To run on localhost, I need a server. I did not have to use anything Python or JavaScript. Since Java 18, there is a binary called jwebserver in the bin directory. And it's meant for exactly this, right? For local purposes, for testing. Please do not run this in production. It's intentionally hamstrung, right? You cannot do authorization, all of that. It's not meant for that. It's meant for, you're getting to learn Java, you're experimenting with the Java backend, you just want to have a simple way to, launch something maybe, stuff like that. Finally, after just 18 versions, now UTF is the default everywhere. But that also means if you are running a system on Windows and you do not have UTF-8 encoded files, and you also do not pass the encoding to the file I/O, then your behavior will change. So in the past, when the JVM launches, it tries to figure out what system am I on, and what seems to be the default encoding here. And on Windows, that would be some Windows or some Latin one or whatever. Like it would pick something that's often correct, hopefully. And then if your files match that, then you could open files and read them as strings correctly, even though you never passed encoding. But the problem with that is that if your colleague runs on Linux or your build server runs on Linux, that goes out the window because the same files and the same code will now at launch time realize, because the JVM will see I'm on a Linux system and these folks are not crazy, so it's probably UTF-8. So it's picking UTF-8 and then the same code will start failing. And for write once, run anywhere, that's not great. So again, if you write code that needs to work on Windows, needs to read non-UTF-8 encoded files, and does not pass the encoding, then you need to revisit that code. And that could mean a bit, depending on how much file operations you do. So be aware of that change. It's a very specific situation in which it fails, but if it happens, it could be quite some work to figure that out. We can now embed code snippets in JavaDoc in a way that is not terrible. Specifically, you can embed it from external files, which is amazing. So we already used that in an open source project where we put all the demos that show up in the documentation and all the demos that show all the code that you want to put in your documentation or in JavaDoc. If you only put that code into the text file and the underlying code that you document here changes, then you have diversions now. And so we're running the proper website is ASCII-Doc, which allows inclusion of files, and now JavaDoc allows that as well. And that's great because what you can do as an extreme way to use this, which I recommend though, you can create a separate source tree, call it demo or whatever, put the files in that they contain all the code you want to show in the documentation, make sure that code is built, that means at least compiled, but you can go one step further. outside of the section that you want to show, you can even set up tests. You can even make sure that the behavior is correct. And then you just pull into Javadoc, you say, I just want to pull in those 3 lines from that file. You do this with regions, so you don't have to like put line numbers. And that way you can make sure that your documentation is always up to date, because it will fail when the underlying code stops behaving the way you want, but then you need to write tests, which can be a lot of extra effort. You probably don't want to pull directly from your tests, because those tests get refactored in a way that does not keep in mind that this code is shown somewhere in documentation. Now the documentation looks ugly. So I think it should be a separate source tree, so I'm not sure whether you want to go all in and put tests there, but at least it's compiled. That's already a step forward. If you use the JDK flight recorder, it can now scrub information, which is good. If you have, you don't want to, for example, put user passwords or something into the log file. And JFR now also has a view command, which is pretty nice. So JDK flight recorder observes your running application and dumps all the info into a file. And then you have different tools with which you can look through those files. But if you don't have a tool handy, or you just want to have some quick info, it can be a little bit annoying. There's now a view command, which you can use to just say, show me the high-level summary, and then you get some stats there. Not even sure that's just high level. You can actually drill a little bit deeper. But it's just terminal output, so it's not graphical. But it's a good first step to check certain things. Okay, last topic. Then we'll see whether we want to go back to the first 2. But well, again, I'm here all day. Okay, so on-ramp. Java 21, as well as some previous versions, and specifically also some future versions, are making life easier for new developers and new Java developers. So those are people who learn programming for the first time, but also people who learn Java programming for the first time. So in Java, we're used to using IDEs, build tools, all that kind of stuff. And usually we kind of assume that everybody knows that. But that makes sense at a Java user group, right? Most people who come to a Java user group are fairly experienced Java developers. But that's a selection bias, right? All the people who are like just learning Java, just learning programming, they're not going to come to a JUG. And all the people who stopped using Java because they couldn't get Maven to work, they're gonna also not be here at the Java user group. So I doubt that everybody actually does know all of this stuff. Usually, by the way, when I'm at a larger conference and the group is larger, I'm making the additional statement to say that in a large enough audience, even there, especially at a conference where there's lots of different topics, people will be in my talk who don't know Java actually. But beyond that, maybe you want to show your kids how Java works, right? Minecraft, Slate Aspire, by the way, also written in Java, very cool deck builder. Students kind of need to learn this language, or we want them to still need to learn this language, right? We don't want everybody to learn a different language or exclusively a non-Java language when they start out. So that would be cool if students also have an easier entry path. Maybe you're front-end developers or data scientists or just some other developers who want to switch or evolve their career, or maybe just are interested or just their job requires them to now also dig around in the Java backend. And maybe it's helpful if they have the learning path that does not start with install IntelliJ, install Maven, install SDKman, public static void main in the whole public class. And now we're going to go over all of that before you even wrote your first hello world. So that's not great. Machine learning AI forks, I kind of included them just now. So Java needs to be approachable. It needs an on-ramp for new developers and new Java developers.
But you forgot the most important point, that ChatGPT-4 doesn't know these new features.
Yeah.
So it's guaranteed.
Yeah, that's a good point. I have like the whole AI coding assistants. I have like a whole paranoia about that, what that will do. Like the gist of that paranoia is, if these tools learn, like the big corpus of code right now is old code, clearly. Old code, I mean, compared to Java 21, right? So they'll mostly learn that. And my worry is that there will be mostly proposed solutions written in that style. And that then if you don't use it in a good IDE, which will immediately yell at you and tell you, hey, there's like user record for this or whatever, then you might produce code, even though you're running on Java 21, that would still technically work on Java 6. And the corpus of old code gets larger. And then the training data is worse. And I'm pretty sure that it's universally true, but at least it's true for most of the machine or all of the machine learning models maybe we built so far, that if you keep the system learning on its own output, it's not going to get better. So right, so that's my personal thing on the whole coding assistant. I'm worried more about the impact on the community as a whole, but also that's maybe temporary. Maybe they will find solutions for that. Okay, so to write and run a simple Java program, what you need is a JDK. You need an editor. You could use an IDE for that. You need Java C, or you could use a build tool or an IDE for that. Then you use Java for that. Again, the IDE can help, and then you have to write some Java code. So it looks like the IDE would be like the one stop to solve this. And with stuff like Visual Studio Code or the new IntelliJ IDE, that does get more reasonable to propose. But I still want to also add that for most people who start out with programming, who start learning this stuff, a full-blown IDE is by far the most complex program they ever opened. Because IDEs are among the most complex desktop applications there are. I think the only thing that comes close is like image manipulation, maybe like Photoshop or video editors or something. Or like maybe full-blown Excel, but again, that's basically an IDE for domain-specific language. So it's this is a complex proposition, right? You can just like, for me, it's easy to install a new IDE and kind of find my way around the basic points, but for a beginner, that's not at all the case. So it would be nice if it would not be required at the beginning. And then the Java code is arguably even worse. So in this case, which we all know how that works, right? But what do I need to explain to somebody who learns this? What's public? That's visibility. What's class? Well, that's a class, and then also, but you have methods. And then what's static? That's a great one, right? They can easily spend as much time as on the other questions on just explaining static versus instance. Then you need to explain what this is and void, and there could be different ones and blah, blah, blah. And then what this is. I mean, not just what this is, but also what the brackets are, but also in general, what is this declaration up there? And we all know this, and that's why it seems trivial. But if you just want to create Hello World, you at the moment either need to know this, or you need to have the curiosity beaten out of you by your teacher who tells you, no, we ignore that now. We come back to it later, which is also terrible. Like, it's not if you are curious and then somebody tells you, no, I don't want you to be curious. It's at least not about this. It kind of like, removes your drive. So there's a lot of stuff in there that is clearly important for full-blown development, not so much for Hello World. So overall, what I just described is not harping on Java in general. The detailed toolchain, the fact that we have, like, if you include Bazel and if you do not include AND, like 3 really, really good build systems. We have at least 3, you still want to count NetBeans, 4 good IDEs. We have unimaginable numbers of web frameworks, we have servers, we have unit testing tools. That's great. We have a very detailed toolchain and a great and refined programming model. But the problem is, as a beginner, that's all a downside. So for the first, I don't know, half year, 2 years of your career, that sucks, that there's all this choice. Oh yeah, don't get me started on where do I get a JDK from? Because there also is like a million different companies out there. I work for one, which I didn't mention in the beginning. But anyway, so it's not, for the ecosystem as a whole, that's good, but for starters, it's not good. So let's change that and make that simpler. JDK 9 added JShell, which is, if you haven't used it yet, it's a REPL, a read, eval, print loop. You start it with a binary from your terminal, and then just write Java code and evaluates as you go, which I don't like very much, to be honest. I don't think it's not great for me. I don't think it's great for beginners either. Maybe I'm not saying, some people do use it, but things that I miss, for example, are syntax highlighting, are when I hit like tab, the code completion has no other choice than to give me like a huge block of options. And then if I have something that works, how do I get that into a way that I can reuse? So I personally don't find it, I think it's good that it's there. I sometimes use it, but I don't think it's like the big killer features for beginners. So I think more is definitely needed. Java 11 added single source file execution, which I think goes much further. You can now say Java and then just a Java file. Note that there is no compiler involved, at least not visibly. The compiler, of course, works under the hood. It compiles into memory and then it runs the bytecode from memory, but you can remove the Java C part of the whole toolchain, which if you're a new developer, specifically if you're not used to the terminal, that's great. That's a whole cryptic command that you have to Java C space dash CP, whatever that means. And then, like you have to list all the source files, or you do some Linux terminal magic with like backtick, find me all the source files in this folder. It's not great. So this is cool for beginners, but it's just one section. All it does is, well, I have some code, I can run it simpler now, but just as long as a single source file. It's a good section of this on-ramp from, where the beginners are to the highway of Java concepts, but it's just one part of that. And now we get 2 expansions of that on-ramp. In the simpler way and also in the more complex way. The simpler code way is a removal of a lot of requirements. Main method no longer needs a string bracket args parameter. It no longer needs to be static, doesn't need to be public, it doesn't need to have a class even. This works. This is not This is not a part of a source file. This is the source file. Void main, and then your code. You could argue why even need the main? Could we jump out of that as well? And technically that has been possible. The decision against that was made because then you have implicitly local variables, and local variables behave a little bit different than at fields. So it's good that you have this kind of like as a lowest, as an atomic piece, you do not have the statement, but the next piece above the method. And arguably you have to learn about methods very soon anyway, because if you want to explain to somebody what this is, it's a method call, and this is how you declare a method. Also, the system out print line is terrible. That will also be made unnecessary in the future.
But can't you just statically import print line and then forget about the system out?
It's not static.
Oh, it's not.
Yeah, this is static, the out. But so we're going to get a shortcut, which basically, I think the process is just a new class that has these methods that passes them on. Like the system out print line is terrible for different reasons. It's like, so first of all, you have to explain somebody what this chain is. Then this is a public, is it final even? I think it's not even final. Is it public? It is final, right? But it has a get set out method still.
Yes, but you can change it.
Yeah. So I have this thing. So you have a public static instance of that, and then you call methods on that. So you after we explained that, which is already complicated, you then have to follow it up with, but please don't do this yourself. So it's not good. There's a preview feature in JDK 21, and as I said, like the whole print line, and also reading from the terminals. Also another example where Java, reading stuff with Java, specifically before Java 8, it's all possible, all the pieces are there, it's all great, but man, is it cumbersome. Now you have stuff like, files read all lines, just give you a string or like a stream of the individual lines. And likewise, reading from the terminal could become easier. And so this new code, this new class will make those things hopefully easier as well. Okay, so now you've made it easier to write like the first little program. Now you can just run it with Java proc.java. That's good. But what do you do if you want to grow your program? This only works, as far as I've shown you, for several methods in the same class. You could add several class files, several classes in the same source file. But it starts to fall apart when you turn your learning experience into the first actual problem solving, which requires more than maybe 100 or 200 lines of code. Sooner or later you want to go into multiple files, maybe even pull in a dependency. This now works as wait, does it work already? It says probably preview in Java 21. It is a preview in 2022. This probably is outdated. It's a preview in 2022. You have a little source tree here, which contains your program, but also already a second source file. And then you have a subfolder, which for crazy reasons, you gave an uppercase L as a folder name, which you wouldn't do on Linux. But anyway, and then you have it a library.jar, you have the library in there. And then you can do this. You can give the Java launcher, the class path, and the file. And note that helper Java is not referenced here. When it compiles proc Java, it will see, oh, there's a reference to helper Java. And then it will look it up in that same folder. And you can also already use folder package structures if you want to, and then we'll look it up in the right, it will assume that the folder structure and the package structure matches, and we'll then look that up. That's all good. What's missing from this story still is, where did I get library.jar? Like, it's not that easy to actually get a jar for dependency, right? Like without a build tool, what, you're gonna go to, I don't know, Maven Central and download manually? Or in the past, at least some project websites still used to contain their jars. I'm not sure whether they still do that. So that part of the story is a little bit unsolved. That works better in a classroom environment where the teacher would provide that jar. But maybe we get some solution for that in the future as well. And the combination of these features is really, really great. It gives you a very natural progression. You start with just your main method, right? It's just like a little hello world that you have there. And then as the problems become harder, you can present, as a teacher, you can present to the students the solution, or to the learner, right? If it's already somebody who's programming, as they need them. So instead of telling them early, this are all the other concepts, or telling them ignore all of this, you can pick the path that I think is best when teaching, which is give people something that works, and then you give them a task that requires something else. And as soon as they arrive at the point where they're saying, but how do I do this? I need this now, this knowledge. That's the best way to learn, because now they've learned, they arrived at that point on their own where they need to know the next step. And then you can tell them, this is how you add arguments to your program, like external command and arguments. If you need to organize code, you add methods. You can have fields that share state between the methods. You can then explore JDK APIs that have become simpler, right? Like reading a file is much simpler. It's really just files and then read lines or read as string, and then you get like the entire content back. If you need more capabilities, you can go into simple libraries. If you need more structures, you can start going to multiple files. That will also work now, as a preview in 22 at least. And you can already use visibility and packages, but you don't need to do it up front. You can start using visibility and packages once you realize that you need a better way to organize code. And most of that works in any order. So if you arrive here first, you don't need to learn about this. First, you can just start here. So there's like really like there can be very individual paths through this jungle of Java features to get started, which I think is great. So Java's strengths for large-scale development do make it less approachable. The detailed toolchain, the refined programming model. And the idea here is to make it easier to start. Not to remove those things from the equation of professional programmers, but to remove this from the path of learners until they need to know it. Until they actually need to build a jar. That's a good time to tell somebody what a build tool is. Once they are out of the phase where they have like 2 source files that they can fit into one editor, then maybe it's a good time to start talking about IDEs, right? So start as simple as possible and then expand your understanding and expand your tool chain as you run into the limitations of what you're currently knowing. And then hopefully that makes it easier for us to tell the future developer generation to become Java developers. So those of you who are below 40 are no longer the youngest people at all Java user groups. So there's more. That's also outdated. Man, I did not update this set. There was a great keynote by Brian Getz about this at DevOps Belgium. It is online, but anyway, you can look for that. The Brian Getz keynote at DevOps Belgium goes into this. But then there's the JEPs that are linked here, and a video I made in May about all of this. And you've made it. So if you have a weekend that you really feel like you need a headache as well, read my book about the module system. The writing is okay, the module system is cool too, but it's not everybody's favor. You can find me at NipaFX on all the platforms that I'm using, with GitHub, Twitter, which I refuse to call X, also Mastodon and Blue Sky and all of that. But more importantly, I didn't mention it in the beginning, I do work for Oracle, so I have a vested interest in making you like Java. But also we do produce content on YouTube, youtube.com/Java, but also on these 2 websites, insight.java and dev.java. And if you want to learn about, or if you want to teach somebody about how to use certain concepts in Java, go to dev.java, there's a learn section. There's a good chance that you find a good introduction there. If you want to follow Java's development along, what are these JEPs, where do they come from, what are the conversations about, go to insight.java, which is mostly an aggregator of content that happens on the mailing lists, in the JEPs. It's basically observing OpenJDK and making the most interesting things available to you. If you've ever looked at the mailing list, you know that there's a lot of stuff there that is not important to an outside observer, or at least to most outside observers. It's not that terribly important to see discussions on like pull requests, for example. But the more important parts are pulled together by insight.java, so you can follow that. And with that, I thank you very much for your long attention span. Thank you. So if you have any questions about any topic, feel free to ask. If you don't feel comfortable asking in the big round, we can also afterwards, I'll still be here. You can ask me one-on-one if you want to. So are there any questions now? About anything? Everything I explained for you for 2 hours has been crystal clear? Good. Can you put that in writing for my boss?
So with the pattern matching,
yes.
At the moment they integrate that underlying variable, that underscore, right?
Yes.
And they also want to add statements before super.
Yes.
But in the project Amber, I have not really found many JEPs about the pattern matching. For example, constant patterns. Are they just disappeared and they think that's all for pattern matching, or no, are they still in draft and not published yet?
Right. So pattern matching is a long track, right? Java started with a somewhat functional but not very expressive switch statement and pretty much nothing else. And so making switch an expression, adding like the lambda syntax, which prevents fall through, then adding records and seal types for deconstruction or for this exhaustive switch. Those are all steps that enable pattern matching. And in JDK 21, all the basic building blocks are final. But there's definitely more that can come after that. So one thing, for example, that you mentioned is the single underscore. You can now use a single underscore as a, well, not as a variable name. You can use it in place of a variable name or in place of a pattern, and it means I don't care about this. I don't want a variable for this. I don't want to reference this. And the good thing about that is that you can have, it's very succinct, it expresses very clearly, and just like in most or many other languages that have this feature, you don't care about this, but also you can have many of them in the same scope. You can have like 3 underscores when you deconstruct something, so that's all good. You talked about statements before super. At the moment, you know that, right? When you have like a constructor and the constructor needs to call another constructor, the first thing needs to be the call to the other constructor. That's a limitation that is intended to keep us from doing things that can create very complicated track bugs, but it's also a little bit cumbersome. It means I get this parameter, now I want to process this parameter before I pass it on to the other constructor, and like it's not great if you have to do this several times or like as inline expressions of that. So now you can have statements before that. Pattern matching took a little bit of a breather, but it's coming back. So in 23 we have now, it's proposed to target 23, JEP 455, which uses, I think it goes on constant, like primitives, primitive patterns, constants in there as well. So look that JEP up. So there will be more on pattern matching. The basic building blocks are there, but there will be refinements. And just like the first building blocks, it will take time.
But it's not blocked by value Valhalla?
No.
Okay.
No. So these projects are independent, except for the fact that many of the same people work on both. But like technically, they're like I would say entirely independent, but probably there's some link somewhere. But these two are really very different.
No 9's preview or 10's preview?
Well, I mean, who knows, right? So the vector API is in its 7th incubation now, because that one needs to wait for value types. Well, it doesn't need to. It could be finalized now, and then once value types come out, we either do breaking changes, or we are stuck with an API that isn't as good as it could be. So the decision was made, you know what, let's keep it in incubation so that once value types are there, we can make the vector API better, and then we finalize the best version of that API that we can envision, as opposed to 95% of it, and then we always quibble over the final 5 to 10% in the future. Maybe it's even more than that. I'm not sure how important, how big those changes are. But yes, I see no such connection between pattern matching and value types.
Why can't we override finalize anymore?
Right, finalize. Why finalize is removed? So the problem with finalizers is that, so for those of you who don't know, you can implement a method finalize on any object, and then this object will be registered for the finalizer, and this was intended to be used for resource cleanup. So imagine back in the days before try blocks without try with resources, before that you had, before try with resource blocks, back in the Java 1 days, you open a file, you somehow have to close that file so that the file handle gets returned to the operating system, so you let go of the file. And how do you do that? Well, at what time are you done processing that file? Aha, we know when. When the instance that processes the file becomes garbage collected, then clearly nobody is processing the file anymore, right? Because the class, okay, great. So let's take garbage collection and let's take resource management, two mostly unrelated concepts, and let's like really smush them together, because that's always how things work out great. And that's the issue with finalization. The issue with finalization is that it runs in an unknown point in time. It runs in a weird context where all fields of the object could already potentially be collected, and you don't know what's happening. You don't know which thread it happens in. You can revive the object. So if you put it into a data structure that then has a reference to it, it survives. And so all these things make the whole usage of finalization very unpredictable, and leads to resource leaks, for example, or just resources that are just freed way too late. Because when the garbage collector collects, something's up to the garbage collector. If it feels like, oh, there's a zone here in my heap that I split into different zones, and this very old object became unreachable, but there's not enough pressure, it might not clean that up for ages, and then it holds onto the file handle. And so try with resources were invented as a solution to that, and finalization should now go out. There's also so it's complexity for us, and error prone for us, but also it's complexity within the JDK. Garbage collectors, I think, which one was it? Was it the G1 or the ZGC team? One of the two teams once said that there's like, I think 1.5% of their heap overhead comes from just tracking finalization. So that goes out the window, that's also great, right? So overall the system gets safer and simpler to maintain and more performant, But yeah, the price is we have to get rid of the finalizers. You can already turn finalization off. So if you have a good battery of tests for your system, not unit tests, I don't think it will work that well for unit tests. If you have integration tests that boot an instance and then do all kinds of things with it, or if you can afford to test in production because you have very good observability, what you can do is you can have like a regular run, and then you run again and you turn finalization off. And then you observe your system. Does memory consumption constantly increase? Do handles for files or other resources not get closed? Does the system somehow behave weird? Then the reason for that is probably that some finalizer somewhere does something important, and now it doesn't anymore because you turned finalization off. So in the future, finalization off will be the default. And in the even further future, finalization off will be the only option you have. So the recommendation is, if you have the chance to try that now, and if everything behaves great, then good, that you do have no issue. And if you do see these weird behaviors, track down. You have JDK Flight Recorder can give you messages about finalization, when objects are finalized and what's happening there, so you can get insight into what finalizers exist, when do they call it. There could be dependencies. Maybe you need to update those or open a ticket or maybe provide a pull request to solve those. In many cases, the correct solution is try with resources block. In the few situations where it's not, there's a cleaner API which is better than finalization, but still shares some of its downsides. It's more flexible than try with resources, but it has some of its issues. So try with resources first. If that doesn't work, look into the cleaner API and see how we can make that work. Hope that answered that. Good. Then I'm going to relieve you. Have a good evening.